thing that you should have done this morning was complete the kind of discovery activity where you were using a number line to model multiplication of integers. And so the first one says evaluate 3 times 2. Well, we always do these modeling ideas or lessons with answers or with problems that we already know the answer to. So we know that 3 times 2 is 6. So because we're not worrying about that in our brain, then we can think about how we model it. So 3 times 2 is really saying 3 groups of 2, right? So then I draw 3 groups of 2 on the number line. 2, 2, and 2. And that gives me positive 6. Well, then the next one says 3 times negative 2, which means it's saying 3 groups of negative 2. So if that's the case, I move 2 to the left, 2 to the left, and 2 to the left, which then leads me to get negative 6. So in the table, it's asking you to think about what your addition sentence would be for the multiplication problem and what your answer would be. So 3 times 2, we've already done, is 2 plus 2 plus 2. 3 times negative 2 is negative 2 plus negative 2 plus negative 2, right? So then 2 times 5 would be 5 plus 5, which would give you 10. And then 2 times negative 5 would be negative 5 plus negative 5, which is negative 10. 4 times 3 would be 3 plus 3 plus 3 plus 3, which is 12. And 4 times negative 3 is negative 3 plus negative 3 plus negative 3 plus negative 3, which gives us a sum of negative 12. So then I ask you to think about what you noticed about the signs of the product of 2 positive integers versus the sign of the product of a positive and negative integer. And you should notice that when I am multiplying 2 positives, my sign is always positive. And when I'm multiplying a positive and a negative, my answer is always negative. And it's just because repeated addition of a negative number moves us further or farther to the left on the number line, which moves us farther into the negatives. Okay, so the video is going to pause and it's going to let you get ready to take your notes and your sobat. So you'll need to have your spiral notebook and your pencil. You do not need the addition or subtraction flowchart today, just your pencil and paper. Okay, now we're ready to start our lesson for the day, which always starts with a do now. You have the do now is on the screen. Even though you can't necessarily write on it to use cubes, it may be helpful to remind yourself to note where you would circle, underline, box, evaluate, and solve and check. Okay, I'll be back on in a few seconds so that we can talk about your answers. So the do now says the highest temperature ever recorded on Earth was 134 degrees at Death Valley, California in 1913. That is really hot. The lowest temperature ever recorded was negative 129 degrees Fahrenheit at Vostok Station, Antarctica in 1983. Calculate the difference between these temperatures. So remember, we always read the problem first. We don't write anything down yet. And then I circle my numbers. So I should circle 134 and negative 129 degrees. I underline the question, and in this case it's not the question, right? It's a statement that says calculate the difference between these temperatures. And I box the key words, and here the key word is difference, which lets me know that this is a subtraction problem. So then I evaluate, which means I set up my steps. So I have 134 minus, because it's a subtraction problem, right? Minus negative 129. Well, Well, I have a subtraction problem, so I'm thinking about my flow chart and I'm thinking about what steps I need to take, and that means I need to LCO, which then turns into 134 plus positive 129. And so the difference, even though it turns out to be a positive number, the difference between the highest temperature and the lowest temperature is 263 degrees Fahrenheit. If you have questions, make sure you write them down so you, during our office hours, you can hop in and ask them. All right, so take a few seconds. Our objective is pretty short and simple today. We are multiplying integers. All right, the one thing that the discovery activity doesn't talk about, right? It first talks about if we have the same signs and they're both positive, if we're multiplying a 4 times 2, the answer is positive, right? What we don't talk about is what happens when I take a negative times a negative. And this gets a little confusing and a little strange because when we model it on the number line, it is really, this is saying that we're multiplying, we're finding the answer to, or the product of the opposite of 4 times negative 2. So on a number line, I would first do 4 times negative 2, which means 4 groups of negative 2. So there's negative 2, there's negative 2, there's negative 2, and there's negative 2, which is negative 8, right? But see, because this negative is hanging out in the front of this, it's the opposite of 4 times negative 2. So the opposite of 4 times negative 2 would be on the opposite side of the number line, which would be 8. So negative 4 times negative 2 is positive 8 because it's the opposite of 4 times negative 2. Now, I understand that that can be a little bit tricky to think about, but if we go back to the beginning, we notice two things, right? If we have the same signs, the answer is always positive. And if we have different signs, the answer is always negative. So we're going to say under here, and what do we notice? We're going to say same signs equals positive product. Different signs equals negative product. All right, so I'm just going to walk through a few examples here just to make sure we understand it. First, we have negative 2 times 5, or the opposite of 2 times 5. So this is negative 10. And then, just to push our understanding a little bit further, we've got negative 1 times 2 times 3. Just like addition, I have to take this kind of two numbers at a time. So I'm going to do negative 1 times 2, which is negative 2, times 3, which is equal to negative 6. Okay. All right. So below, you have an opportunity to solve these problems on your own. The video will pause, you'll insert your answers, and okay, here we are. We have negative 5 times 4 is negative 20. Negative 3 times negative 9 is positive 27. And 2 times negative 3 times negative 7 is positive 42. Here we have different signs, right? So the answer is negative. Here we have the same signs, so the answer is positive. And here we we'll eventually get to same signs because 2 times -3 is -6 times -7. Same signs will always equal a positive. Okay, so now if you need to, go back and watch the short little video again, just in case you don't understand one of the things that we have talked about. And then you'll have an exit ticket in Schoology. I hope everybody has a great weekend, and I'll see you